So as I mentioned before, this is the training for the Envirothon Aquatics topic. And, sorry, 1 second. So we'll be running through a few topics today to do with the aquatics. So we'll start out with water and kind of looking at how water moves around the world and what happens to it when it gets onto the ground. We'll also be looking at how we can tell if that water is healthy and the ways that we measure that the health of the water. So some of them will be water chemistry tests as well as a bioassessment. We'll also be looking at stormwater pollution and some of the different ways that water can become unhealthy. So some of the guidelines, just as we're going through, please keep yourself on mute unless you are speaking. Use the chat to ask questions. And if I ask you a question, then please use the chat to respond. Okay, so water, what is it? It's when we have rain and it's made of H2O. And so when water lands on the ground, there's a few different things that it can do and ways that it can move. So if it depends on where it lands, so if it lands on a soft surface that might be made up of plants or vegetation, then it will be able to infiltrate into the ground. And so there's a few factors that kind of determine whether or not the water can actually infiltrate. And one of those is going to be the slope. So how steep an area is. So if it's a really steep slope, then the water won't be able to sit there for long enough to kind of go down into the ground and infiltrate. Another factor is going to be what that surface actually looks like. So if it is soft and has plants or some soft soil and there's actually pores where that water can go down into the ground, then it will infiltrate and join into the groundwater. But if that surface is really hard, like our pavement or our roofs, things that we find a lot of the times in the city where we have a lot of people, then that water will pool up and it will have to run off instead. The saturation of the soil can also kind of determine where that water goes. So if you already have a lot of water that's filling the pores in the soil, then the new water that's landing on that area won't be able to soak in, and instead it will run off. And because water behaves this way when it lands on the ground, it forms a watershed. And so a watershed is determined by the topography of the ground, so kind of where all those different slopes and peaks of the hills are. And so if it's the watershed is defined as being an area of land that all drains to one area. So as you can see in this picture, we have water that is falling in these mountain peaks and will then melt and form runoff. And it all is draining down this area into what eventually is the ocean. So it starts as very small streams high up in the peaks and then joins up into larger rivers. And so as we move down towards the ocean, we have smaller streams that are joining up with other smaller streams, and those rivers are getting larger and larger as you approach the ocean because more and more water is being collected. So in a watershed, things like forests are really important for helping to keep water clean. So that's one sign of having a healthier watershed, is that there's a lot of different types of plants that can absorb that water and prevent any pollutants from ending up actually in the water bodies that form the surface water. So as water infiltrates into the ground, it might join up into an aquifer, which is kind of an underground area that has a lot of pore space because it's usually made up of like sand and gravel. So depending on where you are, those areas, they were formed by the glaciers a long, long time ago. And they're kind of deposits of different materials that the glaciers brought down. And so we actually have a lot of aquifers in southern Maine where all that sand and shale was deposited. So we get a lot of our drinking water from groundwater, but in other areas, you might be getting your drinking water from the surface waters because that's just more available. So some of the things that we look for to see if water is healthy is going to be having a lot of diversity. And so that might be the things that are living there. And it might also be the habitat as well, because to support a lot of different types of species, you also need to have a lot of different types of habitats for those creatures and plants to live in. Some of the other signs that we use to see if it is healthy is if we can use it as humans. So we will get really sick if we're drinking and using polluted water. So we do a lot of tests to make sure that it is clean and healthy. So one of the things we'll check out first is a tool to see what watershed you are in. Sorry, I just have to find how to share that. Here we go. So this is a tool from the EPA, and you can just enter your address. So I'll use our address here at the Cumberland County Soil and Water Conservation District. And this tool is really interesting because it will show you kind of one of the main watersheds that you're in. So kind of up at the top right, which shows us that we're in the Dundee Pond Upper Presumpscot River watershed. So the Presumpscot River runs from Sebago Lake down into Casco Bay. It comes out kind of on the Portland-Falmouth line. And so we're in the drainage area where all the water that lands within this dotted line is coming down into the Presumpscot River. And yeah, so this tool will tell us a lot about these different water bodies and their health as well. So we can click through these different tabs and see if they are in good enough condition for swimming, which you can see we have several that are. One thing to keep in mind is that not all of this data might be current. So some of it might be a little bit older. It will also show us if we can eat fish or different aquatic life that they are measuring here, as well as some of the places where we might be receiving drinking water in this area. So if you aren't sure what watershed you are in, that's kind of a cool tool to figure out where what watershed you are located in and some of the different water bodies that are located around you that might be contributing and bringing water down into that water body. So we'll switch over and look a little bit more at some of the water quality parameters that tell us if water is actually healthy. So there's a number of chemical tests that we can do to figure out if water is healthy. So some of them are harmful bacteria, clarity, temperature, dissolved oxygen, algae, and hazardous chemicals. And so these are all things that we can look at and measure in the water to determine whether or not that water is going to be safe for us to use or healthy enough to support wildlife. We don't need to do that part. So algae is something that does occur naturally in an ecosystem, especially in aquatic ecosystems. It's a microscopic plant that uses the sunlight and carbon dioxide. It produces its own food and it releases oxygen. So in a lot of ways, algae can be really great, but the problem comes when we have too much algae in an ecosystem. It can have really bad impacts on the health of that water. So for humans, some of those impacts are that it can affect the taste and smell of the water. It can become toxic, so it can actually harm our survival, or you might have heard of some of these algae that get into ponds that might kill dogs that are living there as well. And it can be really expensive to filter out algae. So from a human's perspective, it's a big cost to remove it from a water body and to fix the issue once it occurs. For the aquatic life that lives in a body of water, some of the issues and impacts there are that although it is the base of the food web, if it is not being all consumed by the animals and creatures above it, then it's going to kind of overwhelm that ecosystem, as you can see in this picture here. So when we have too much algae growing, it is called an algal bloom. And the issue with this occurring is that all of this algae will then die all at once. And when it dies, just like plants on the ground, it's trying to break down and decompose and turn back into soil. And that's a process that takes a lot of oxygen. And so when that process is happening in the water, it soaks up a lot of oxygen from the water, and then it's not available for the animals and creatures that need to use it to live in the water. So we'll look at this. So I guess I know we have one group on the call today. So I'd like you to make a guess as to which of these measurements you think is going to be the healthy end of this range. Can't actually see your screen. So I guess if you want to unmute yourself and just say it.
We think 4 or 6.
Can you repeat that? Sorry.
Two, 4, or 6.
Yeah, so somewhere in the 2 to 4 range is going to be a healthy reading. So a 0 would be a little bit too unrealistic. And we do want some amount of algae in the water because, as I mentioned before, it is the base of the ecosystem and the food chain and supports everything that is living above it. So that 2 to 4 is going to give us a little bit of food to support the ecosystem, but a 10 would be completely overwhelming. So just a quick review of those. All right, so the next one that we'll look at is clarity. And so clarity is measuring how clear or cloudy the water is. Another word that we might use for this measurement is called turbidity. So we might measure how turbid the water is. So some of the impacts of this for humans are that it's a sign to us that there's a lot of pollutants in the water, because when we picture a healthy stream, it's usually clear. We can see the bottom. And if it's cloudy, that's a sign that there's either a lot of movement happening in that water, or it's coming out of something like this storm drain, where it's bringing in rainwater that has picked up a lot of pollution. And once again, it's a really expensive process to remove sediment or other pollutants that might be floating in the water that are impacting the clarity. Some of the impacts for aquatic life are going to be that it is difficult for them to see or breathe in cloudy water. So if you think about fish, they're trying to receive their oxygen through their gills. And if there's a lot of sediment and things floating in the water, they can't really control whether or not it's going into their gills. So it's similar to us. We want really clear, healthy air that isn't full of smog and different chemicals. And if it's cloudy, then it's going to be harder for them to find their food as well. Oh, God. So another thing that can happen when we have a lot of things in the water that are making it cloudy. So a lot of the time, that's just going to be soil. And we'll talk a little bit more about that later on. But what will happen is it's cloudy because there's tiny little pieces of things that are floating around in the water. And as those things start to settle down into the bottom of the stream or lake, it can actually end up changing the habitat completely. So a lot of different types of aquatic wildlife prefer a rocky, gravelly bottom. And that's just a system that's going to support more different diversity of species in that area. And so as these particles are settling down onto the bottom of the stream, they will fill in all those gaps around the rocks and the gravel and can make it a completely different type of bottom, which can affect the different living creatures as well as the plants as well. So we'll look again at some samples, and I'll have you guys guess once again, which do you think is going to be the healthy rating?
Six or eight.
Yeah, so as clear as possible. Really, we would love to see a 10, but that's not always going to be feasible in an actual natural system. So the next test we'll look at is temperature, and this is going to be important for the things that are living there, especially, but it can also have a big impact on and relate a lot to the other water quality parameters as well. So some of the impacts it has on us as humans is that warmer water is going to speed up different life cycles. So if there's things like the algae or the bacteria that are getting into water, those are the things we don't really want to be there in large quantities. And warmer water is going to make them grow and multiply much quicker. So those are also the things that can make us sick. And so if there's a lot of them there, then we can't use that water. For aquatic life, colder water is going to hold more oxygen. So if you think about oxygen being floating around as little bubbles in the water, and think about water being tiny little molecules as well. When water is really cold, those molecules move really, really slowly. And when it starts to warm up, those molecules move really, really quickly. And if they're bouncing around and moving really quickly, they're going to push that oxygen up out of the water. So the colder water is moving a lot slower, and it's going to hold on to that oxygen for a longer period of time. So temperature for a lot of animals can determine what types of animals are able to actually live there. So you hear this a lot around climate change, where we start to see different species that might be living in our waters, and it actually becomes a little bit more suitable if it's warming up to some types of invasive species that might be kind of edging out of their natural range and coming into the main waters. And so naturally, we are pretty far north, so a lot of our native species are going to be more adapted to colder climates. So we'll take a look at these different temperature readings and see if you can guess which ones might be in the healthy range. So we have 43 degrees Fahrenheit, 62 degrees Fahrenheit, or 73 degrees Fahrenheit.
43.
Yeah, 43 to the 62 a little bit. So we definitely want colder waters, but seasonally, it's not always going to be quite that low. Okay, so that brings us to dissolved oxygen, which I talked a little bit about with temperature because they are so intertwined. And oxygen can really be very dependent on the temperature. So some of the impacts we have on oxygen or on humans. So we'll watch our little crayfish here, and you'll notice that the stream that this crayfish is wandering through has a lot of bubbles floating around in it. So that's a really good sign that this stream in particular is very oxygenated because we can see that there's signs of bubbles there. And so as humans, we don't really have a direct impact. It's not going to harm our drinking water, but it does harm some of the things that aquatic life need. And not seeing a lot of oxygen, often a sign of there's something that might be wrong with that body of water. So of course, having more oxygen in the water is going to support more aquatic life. So the things that are living underwater, even though they live there and they aren't breathing oxygen the same way as humans do, they still need to have a lot of oxygen available to them. So things like this salamander also needs to be able to receive oxygen underwater. So a couple of the ways that oxygen gets mixed into water is one through the wind. So you might have seen a really windy body of water and it kind of gets those white caps on top of it. And those white caps are a sign that there's a lot of bubbles and oxygen being mixed into the water. Another is the way that a stream might be flowing. So if it's going over a lot of rocks and kind of tumbling around over ripples, then it's kind of mixing a lot of water in naturally, and like waterfalls as well. And then the third way would be for if there are the plants that are growing in the water. So just like plants on the land, those plants are producing oxygen, which then gets dissolved into the water and made available for the different aquatic life that needs it. So take another guess. Which of these jars do you think has more oxygen? Gia, easy guess.
So muted. 10.
Yeah, so we have a lot of oxygen going in. We can see that there's a lot of bubbles. Oops. Interesting. All right, so our next one is going to be harmful bacteria. So they're the bacteria that are found on the intestines and then the feces of different animals and birds. So for humans, this is a really big issue for us if the water has a lot of bacteria in it. It causes a lot of like diarrhea, vomiting. We have a lot of issues if we end up eating that bacteria. So kind of the well-known bacteria that you might have heard of is E. coli. So oftentimes they have to close beaches if those areas have too high of an E. coli count because they're not safe for humans. But for many of the aquatic life, there's not a lot of impact to them. Okay, so hazardous chemicals is another thing that can end up kind of harming the health of our water. It, of course, has a lot of impacts on humans. As we mentioned, they're very harmful. So they can give us headaches, skin rashes, kidney damage, stomach problems, a whole lot of different things that would not lead to human survival. For aquatic life, it can lead to mutations, damaged body parts, weakened immune systems, and eventually death if there's too much. All right, so I'm going to switch back to my other presentation. I guess I'll take a pause. Does anyone have any questions about the things that I've said so far?
Jenna, can you explain the impact of algae growth and what algae blooms indicate? You talked about vegetation being an indication of health, but I think many people will argue algae doesn't fit in there.
Yeah, so algae is really a sign that something is happening in the water system that is adding a lot of nutrients into the water. So the algae is growing because there's too much food. It's usually going to be nitrogen and phosphorus that are causing the algae to grow excessively. So I'll talk a little bit more about some of the pollution that causes that excess nutrients in a little bit, but kind of a brief summary is fertilizers that people are putting on their yard, pet waste, and then erosion and soil that's running off into the water is carrying a lot of nutrients with it. And then as that algae receives that extra nutrients, it grows really quickly, but it has a pretty short lifespan and it dies pretty quickly as well, leading to that oxygen being removed from the water, which can end up leading to big fish kills. Are there any other questions?
Thanks.
Okay, so the next way that we can look at water to measure its health is by looking at the things that are actually living there. So we call these benthic macroinvertebrates. So benthic refers to how they live on the bottom of the stream. And macro is that they're small, but they're still big enough that we can see them with our bare eyes. So we don't need additional tools to see them. And then invertebrate just means that they don't have a spine, so they usually have a hard exoskeleton, or they might be soft and wiggly like a worm. So we use macroinvertebrates to determine if water is healthy because unlike the water quality parameters that I just discussed, those are kind of snapshots into what that water was at that exact second that you took that exact sample of water. And so from most of those bodies of water that we are testing, that water is moving really quickly through the ecosystem as it flows downhill. But these bugs, they live there all the time. And so they can give us a little bit of a better idea over the long-term health of the water body. So I'm going to switch gears once again. So there's a couple different ways that we can measure the macroinvertebrates that are living in a stream. And so we know that most of them will be living in areas where there's ripples and a lot of oxygen mixing into the water. And they also prefer a rocky bottom in a stream as well. And so one way that we can collect them is by leaving rock bags in the stream. And so we're kind of just laying a trap of this is your preferred habitat, and they'll kind of gather in that space. You can remove the bag and then rinse all the rocks off, and look at the bugs that have gathered in there over a period of time. Another way that they can be collected is using nets. And so that's kind of a quicker method to do it. You use a kick net and like use your feet to kind of kick the rocks and the things that are on the bottom of the stream where they might be hiding or clinging to. And you put your net downstream and all the bugs get suspended in the water and then hopefully go straight into your net. So there's an example of a kick net. And so a lot of these bugs, it's important when you're removing the rocks from the stream to kind of wash them really closely because their job in a stream is to stick to those rocks and not get washed away, so they can cling on pretty well. So these bugs are important to tell us about water quality because some of them are really, really sensitive to pollution, where some of them can live anywhere. They're very tolerant to pollution. They don't care if it's horribly polluted or incredibly clean. They'll be found anywhere. So when we do a test, it's most important to look and see what bugs are in this group 1, which is considered very intolerant of pollution or very, very sensitive. So those are the species that need that cold, clear, oxygen-rich water. Whereas the other ones can be a little bit more flexible in their needs. So a few of the macroinvertebrates that we might see in a stream, some of our ones that are very, very tolerant of pollution are going to be things like the pouch snail, this horsefly larva, and a tubifex worm. Some in our next group, so group 3, they're a little less tolerant, are going to be a midge, a leech, and a black fly larva. And then in group 2, so we're getting pretty sensitive to pollution. We have a dragonfly larva, a damselfly larva, a riffle beetle, and a scud. So you'll notice, or I guess I'll talk about these ones first. So our very, very sensitive macroinvertebrates, the ones that can't handle any pollution, can only be found in really, really clean water, are going to be the stonefly, the mayfly, the caddisfly, which both of these are actually versions of the caddisfly. One just builds a house around itself. The other might use some different methods. They don't always have a house or a cocoon. And then the last one is a Dobson fly larva. And so some of the key things that we use when we're identifying them is the number of legs and the number of tails. So between the damselfly and the mayfly, you might notice like they look pretty similar. They both have 3 tails, but they do have much different body shapes where the damselfly is kind of long and skinny. And those are actually the ones when you see those skinny blue dragonflies, those are actually the damselflies. So as when they're in their larval state, they look much different compared to when they are in their adult flying around hatched dragonfly state. And then the caddisfly, so I mentioned that it builds this cocoon around it. So that's something that it does with kind of a sticky glue that it produces. And depending on the bottom of the stream where it's living, it might be made up of pieces of sand and gravel, or if it's more of a wooded area, it might be made of sticks and pine needles. So they kind of just use whatever they have around them. All right, any questions about macroinvertebrates? Okay. All right, so now we'll move on to talk about some of the different types of pollution that can make our water really unhealthy. And so we'll be looking at what does it look like when it's in the water? So is it affecting things like the clarity, or is it affecting the temperature through that as well? Or yeah, so we'll look at how it's impacting the water quality. So to start, we'll look at dog poop and soil. So those are two things I had mentioned before that impact the growth of algae, because one of the big things that they do is contribute nutrients like nitrogen and phosphorus. They can also contribute to the clarity of the water, which in turn contributes to the temperature of the water, because if we have cloudier water, that can make water heat up much quicker, because all those tiny particles that are floating around in the water, those attract heat and can then make that water warm up. So I have a couple of jars. So this one shows what dog waste looks like in the water. And so at the back of this jar, you might be able to see that there's a Secchi disc back there. I'll show you the clear one so you can see what a Secchi disc looks like. So that's what we use to measure the turbidity, or how clear the water is. And so normally you would have one of these discs on a string and you would lower it down into the water. So Secchi is spelled S-E-C-C-H-I for reference. So when we have dog waste in the water, you can see that it does make it a lot cloudier than the clear jar, which is kind of gross. It's all floating around in there. This also adds that harmful bacteria into the water, and so it promotes that E. coli growing. And so if it's getting cloudier and it's getting more bacteria growing into it, and it's warming up because it's cloudy, then it's going to create a pretty bad situation. Dog waste is a pretty big issue in areas where people bring their dogs to walk a lot and don't pick up after them. And then, so soil is our other one. So this happens when soil erodes off of the land. So if you just have bare soil down on the ground, then it's really easy for water that is flowing across the ground to pick that soil up and erode it away from where we want it to be on the land. Soil is actually Maine's #1 stormwater pollutant. So it's the thing we see doing the most harm to water bodies the most frequently, because as similar to the dog waste, it's carrying a lot of sediment into the stream. And as I mentioned before, that sediment can then end up changing the bottom of the stream surface and completely changing that ecosystem. It's carrying massive amounts of nutrients with it. And soil on the ground is actually fantastic. So that's another important thing to note, is that when we have soil on the land, that's exactly where we want it, versus when it washes into our water bodies, that's not really a great spot for it, and it leads to a really unhealthy ecosystem. All right, so the next one we'll look at is car oil. So you can see with this one, it is probably a little bit more apparent in this jar that there's car oil there than when you kind of just see a little bit of a sheen on top of the water. but it doesn't take much oil to contaminate a large portion of the water because it spreads out in that thin layer across the top. And so I'm sure you can not see that Secchi disc in there either. So another stormwater pollutant that we have a lot in Maine, which we use mostly seasonally, is going to be sand and salt. And so we put that down on the roads because we need to be safe in the winter. But what happens in the spring when all that snow is melting is it picks up that sand and salt, it carries it away from the roads and into our rivers and streams. So you can see that similar to the soil, it's making that water really cloudy. And then the part that you can't see as well is that there's also salt mixed in here, which when it gets into a freshwater ecosystem can make it a really difficult environment for freshwater plants and animals to survive there. So herbicides are something that we put down on our yards to prevent different plants from actually growing there. And you can see in this jar that they don't actually affect the way that the water looks. So you can see that Secchi disc pretty clearly, but what you can't see is that it's adding these harmful chemicals in that are going to make it really difficult for the things that are living there to survive. Because if those chemicals are harming plants that are on the land, then they're likely to continue harming plants that get into the water as well. Another pollutant that we see frequently is going to be litter. So that's pretty easy to see when it gets into the water. We can see that pretty well. They are stickers on the jar, so it's kind of just to give you a reading. Yeah, so they're not really going to affect the clarity of the water for most types of trash and litter, unless they block the Secchi disc on the jar that you can't see it. And then the last one I have is fertilizer. So you can see that when it gets into the water, just as the chemical itself, you can see pretty much straight through the jar. It's not affecting the quality that you can see, but it is adding a lot of the nutrients, the nitrogen and the phosphorus into the water. And as we know from what we discussed earlier in the water quality parameters, is that those nutrients that are being added to the water, even though you can't see them now, in a little while, that algae will explode with growth and this water would end up turning green. And then eventually removing all the oxygen as well. Okay, any questions about the different types of pollution? Or how they impact the water quality?
Could you talk a little bit about the harmful algae, like the toxic ones?
Yeah, so that's going to be the cyanobacteria. So I know that there is at least one pond in Maine that's had it for a couple summers, and it ends up producing, I believe, a chemical which is really toxic in the water. So it's not a chemical in the way that different herbicides and pesticides are a chemical, but it's something that they kind of create naturally, and it gets into the water. So it's not necessarily like the plants itself, but yeah. So Hinkley Park is the area that I know has had that specific type of bacteria, and I believe they ended up closing it for a period of time because they didn't want people's dogs to get sick, because that's a place that's well known for having dogs. And because it's well known for having dogs, there's a lot of bacteria that was going in there that they think also contributed to that problem. So you've got extra nutrients and bacteria, so it's kind of the perfect storm of pollution.
We do a lot of water testing for our local water district for the source of the surface water supply for our town. And I think it was 2 years ago, we got a request to do some sampling for harmful algal blooms and harmful algae. So thank you.
Interesting. Well, I guess I'm at the end of my presentation. Is there any other questions about aquatics in general?
Actually, I was wondering whether Michelle might, if she is still online, might be able to give some idea of what type of aquatics questions would be or may be on the test. You know, is sort of a general in nature. I know you've covered a bunch of the topics that are on the test, but how might those show up as questions that would be in the test?
I can address that. Yeah, I'm still here. Can you hear me?
Yeah, just barely.
Okay. They're usually test questions that talk about the different parameters. Say pH is one of those parameters that we're commonly testing for, and there's different extremes of pH, and knowing the actual range in which life exists and how those different ranges of pH can affect life. I've got a puppy here, hold on. Let's see, also knowing hold on for a second. I've got a small puppy problem here. Anyway, the big questions will revolve around how those parameters interact with life in the pond and how they will affect the life. For example, pHs above 8 or 9 will affect things like fish and amphibians, and pHs below 4 and 5 very often result in large fish kills and things of that nature. The water quality definitions of point and non-point source pollution are very, very commonly asked. We also ask about common pollutants in Maine. There might be something about PFAS on there actually this year, because the PFAS are a pollutant that are coming up in the news quite often. These are forever chemicals. They are found in sewage sludge that has been put on agricultural lands, and it's leached into the groundwater. Groundwater pollution is a very, very big problem. Knowing some of the most common pollutants that affect groundwater, such as MBTA, oil and water, that escapes from underground storage tanks. Things like that are really good to know about. Watch the news, do some research on the common pollutants here in Maine, because those are very often mentioned on the test. That's all I have for you.
Okay. Thanks.
I missed
Michelle.
a little bit of Jenna's presentation, so I don't know exactly what she covered.
Jenna,
Yes.
could you talk a little bit about the difference between like a forested watershed and maybe an urban or non-forested watershed, and the importance of protecting riparian buffer zones?
Yeah, so in a more forested watershed, you're going to have a lot more of the pores and the appropriate surface for water to be infiltrating into the ground, which I talked about a little bit at the beginning as well. But in an urban area, there's going to be a lot more impervious surfaces. So there's a lot less space in the actual pores in the ground for water to soak in. So you end up with a lot more runoff. You end up with a lot more opportunity for that runoff to encounter the stormwater pollutants that we discussed as well. Because as with many things that people do, they're happening a lot more where there's more people. So in that urban environment, you have more people that are contributing more stormwater, which eventually is being washed away in the stormwater runoff. And in that forested ecosystem as well, the plants that are there, when the water is being infiltrated, it has an opportunity to filter out some of the pollutants that I had discussed. So things like the nitrogen and phosphorus that are coming from soil and dog waste, and the fertilizer, if you have those plants available to be soaking up that stormwater runoff before it gets into a body of water, then that pollution can be removed from it before it gets into the water ecosystem and can have those harmful effects on the quality.
Are there some types of plants or species of plants which are better at that nitrogen removal or phosphorus removal? I've asked this question on a fair occasion, and it doesn't seem to be a whole lot of findings yet on specifics.
Yeah, that's a really good question. I don't have an answer for it, but I would add that a lot of the time, some of the best management practices for handling stormwater, they're not necessarily seeking the plants that are absorbing the most nitrogen or phosphorus, but they're seeking plants that can absorb a lot of water. So if they're installing things like a rain garden, then they're going to be putting in plants that love a lot of water and can soak a lot of that up and help to filter out pollution.
It is also interesting to note that plants that require more phosphorus, such as flowering plants and plants that produce fruit and berries, they absorb more phosphorus out of the soil, water, and runoff than other plants do. So that's one of the things I'm always telling people when I advise them to plant buffers around their ponds, is to plant flowering plants and plants that produce fruit or berries, because those will absorb more phosphorus than, say, ornamental grasses or just a green shrubbery.
That's perhaps the clearest answer I've ever got to that question. Thank you.
You're welcome.
Any other questions? I guess one more thing I'll add about your question about the difference between forest and urban is that also when you have more plants and forest, there's more texture on the ground. So even if you have a hill that water might otherwise be flowing really quickly down, adding that texture and things that the water is going to be moving around and navigating around will help to slow it down. So that kind of, if it's moving slower, it's going to infiltrate better into the ground. Any other questions?
Jenna, did you cover any of the lake ecology material earlier?
Not as much.
Okay, something that's very commonly covered on the Envirothon test is things like lake stratification terms, the life zones of a lake. Sometimes I actually include some of the life zones that are also included in marine environments. Understanding things like seasonal turnover of the lake due to where the temperature stratification actually changes over seasonally in the spring and in the fall, and why that's very important to the lake and especially the cold water fish, and oxygen levels. Those are all kind of integral terms. See, I also have things about the layers of, the thermocline, and what is the significance of the thermocline layer? There are a lot of terminology kinds of questions, definitions of all the different parts of the hydrologic cycle. What is transpiration versus evaporation? And being able to label a diagram with the different parts of the hydrologic cycle is really good to know.
The other day near our house, normally there's a huge foot bank on the end of Scoggins, and it was like right up to the end.
With the hydrologic cycle, most kids know it at a really kind of basic level. They understand evaporation, condensation, precipitation, runoff.
And
Could you talk a little bit about some of the other parts to the hydrologic cycle, like sublimation and infiltration, because that sometimes gets lost.
Yes. Let me just see if I can grab a really quick picture. Yeah, so kind of the key parts are definitely going to be the evaporation when water is getting really warm and excited and evaporates up into the clouds. It then condenses, and then we have the precipitation. So what really has a lot of different pathways is after that precipitation occurs. It depends a lot on where the water is actually landing. So it isn't always just going to land in a puddle and then repeat the process all over again. So if it lands high up in a mountain and it is comes down as snow, then it will need to actually melt, would be a step before it will run off. So there's a lot of different energy needs there as well. And when it runs off, it can either then join up with a surface body water, or it can infiltrate down into the ground. And once it infiltrates down into the ground, it might travel through the ground and into one of those surface bodies of water. So the water table is actually always where that surface water is, like the top of the surface water, but going into the ground from there is where the groundwater level would be as well. So they're actually sharing a lot of water between the surface water and the groundwater adjacent to it, because the gravity is always pulling that water down to the ocean. So even through the ground, that water is being pulled towards those streams to be pulled down towards the ocean. But it can also continue going much deeper into the ground as well, into the groundwater. And then sublimation is when it transforms directly from the ice to being evaporated. So that's a little bit less common.
I just threw a
I'll send
website
you-
in the chat that might help you with the image of that.
Okay. And I have a link to a virtual lesson that we have as well that has a review section for all of the different types of terminology. There we go. Yeah, so as I mentioned, we have groundwater that can go much, much deeper down into the ground where it's kind of filling the aquifers where we're getting our drinking water from, if that's where we're getting our drinking water from. But if it stays a little bit closer to the surface, then we see it kind of pop out in springs or freshwater bodies where it's kind of able to pass back and forth through that barrier as gravity is pulling it down towards the ocean. Another path, if it's settling in that soil, is that the plants that are living there are drawing it up into the plant, and then evapotranspiration is going to occur from there. So that's very similar to the evaporation that occurs just out of a water body, but instead of being from the surface of the water, it's coming out of the leaves of a tree. And so we use the word evapotranspiration because that refers to how it's being transported from or transported through the leaves into the air where it rises and condenses into a cloud. Yeah, so you can see that there's also the option for if it's landing in an area where there's snow and ice before it eventually will melt and then join up into the rivers that start kind of high up in the mountains. So I think that's most of it. And I will share a link as well so that you guys can explore that a little bit further. I have some definitions. Any other questions? And then, of course, all of these links will be shared with the email that goes out after this as well.
Jenna, have you discussed invasive species yet?
No. I mentioned it a little bit in terms of kind of temperature as a water quality measurement, and how if we have warmer waters, then sometimes it creates a better ecosystem for our non-native species, and some of those invasives can take off.
Yep. At the Envirothon, we always have an aquatic invasive species identification task. And this involves being able to identify at least some of the key players in the invasive species that are invading our lakes, like milfoil, and well, especially milfoil. If you can't identify milfoil, that would be the basic one to really know. The Lake Stewards of Maine, which is a group that has a website about all the things that they do to keep invasives out of lakes. They have some good identification materials that you can download. One of them is a guide that you can basically key out an aquatic plant and learn how to identify whether it's invasive or not. And I would advise all the students to get familiar with that. The Lake Stewards of Maine website, all you have to do is Google it and you can find them. We usually have like 3 invasives that I put out in trays, or 3 aquatic plants, and you have to determine whether it's invasive or not, and what it is probably, what kind of invasive it probably is if you think it is invasive. Also knowing how invasive plants get into our lakes. There are several methods that we use to keep them out, such as doing boat inspections at the boat launches on lakes, making sure that your tackle and fishing gear is all free of any weeds at all, so that you don't transport weeds from one lake to another. And also, I ask questions usually on methods of controlling invasive plants, like barrier methods, putting large tarps on the bottom of the pond in the area that's infested. And that is one of the methods that they commonly use. Another one is using a suction method, where a diver will actually harvest the plants out of the bottom, and they're immediately sucked up a hose into a boat that has sort of a netting that traps all of the plants, so that they're removed from the lake bottom. And those are all really easy information things to find. I think if you go to the Lake Stewarts of Maine, they have all kinds of information on that.
I just threw a DEP link that has the images of those 11 most unwanted ones into the chat.
Yep, that's very, very important. The big clue about invasives is especially the milfoil group, because they all look very much alike. We have native milfoils, but all of the invasive ones, they have leaves that are feather divided. It means that their leaves have little branches or stems that come off of a central vein, and they sort of look like a feather. And they always come in whorls around the edge of the main stem, where they all come off from one point rather than alternate. And if you can remember anything, just remember that: feather divided and in whorls. And Jenna, did you talk about benthic macroinvertebrates or bioassessment?
Yeah, so we covered just how some of them can indicate whether water is healthy because they're really sensitive to pollutants. And then some of kind of the key ones, if you see those sensitive ones, that is definitely going to be healthier water. Whereas if you see ones that are tolerant, then it could be healthy, it could be unhealthy. But looking for things like a stonefly, a caddisfly, a mayfly, and a Dobson fly are all going to be good signs of healthy water.
Very good.
Okay.
Yes. Any other questions before we wrap up?
Yep, I have a
All right.
coming at you real quick. Hold on. I just Googled the website and threw the link in the chat, but could you talk a little bit about oligotrophic and eutrophic lakes and eutrophication? And there's an image in there of those two.
Yeah, so a eutrophic lake is going to be a lake that has a lot of nutrients that are happening, and the algae are growing excessively to the point that other things aren't really able to be surviving there. It's when we end up having that oxygen that's really sucked out of the water because there's so much algae that's growing there. And then the oligotrophic lake is going to be kind of the opposite of that, where there's very few nutrients available, to the point where it's difficult for things to live there because there's so little nutrients available.
And what would generate that?
That's a great question. So I believe it would be that if there's not a lot of like organic matter near that area. Michelle, do you have a better answer? Oh, she might have stepped away. I don't have a great answer for what causes that.
Okay, I mean, it's not one you hear or have identified as often. Is what I'm
Right.
wondering.
Yeah, we usually hear the opposite, where it's becoming an issue because of too many nutrients.
Typically, the process goes from oligotrophic to eutrophic, right? That's when nutrients get into the water and speed up that process, it ages your lake. So it's usually oligotrophic to eutrophic. It's hard to go the other way.
Yes.
Yeah. All right. Any other questions?
I just have something I'd like to add. I've compiled a lot of study resource information on the Oxford County SWCD.org website. It includes things like the macroinvertebrate keys, information about watersheds, how to delineate a watershed, wetland information, links to a lot of different websites where you can get more information about the properties of water and the distribution of water around the globe and water conservation practices. It's a really helpful collection of a lot of ways to gather information for the Envirothon test. And you would just go to the Oxford County swcd.org website, and if you look under education and outreach, you'll find, as you scroll down, the Envirothon section.
And I just added that
That's
link
where
to the chat too. All right, if there's no additional questions or comments, then I guess we'll go ahead and wrap up. So thank you for joining us today, and I hope that you found this helpful and that you are successful on your test.